Alright, so we have a Glock 43 here, Gen 4, which is missing, or rather, doesn't have MOS cut for an optic, like this. And we have a holosun optic that needs to go in this gun. So clearly, you need to cut a seat for it. Let's see. Thickness of the slide is 0.862, and the optic itself is 0.942. So it's going to protrude, stick out just a little bit, but overall should be quite a good fit for this gun, I believe. Alright, so let's strip this and talk about what we have to deal with here. So this is the slide with everything removed, basically stripped. This is why it's very important. Well, it is very important to do this so that you can account for any obstructions, holes, channels like this that you may run into when cutting away at a slide. So the biggest issues we can potentially run into here is this plunger hole, which is 0.755 inches deep, so about so deep. Clearly it comes almost all the way to the top of the slide. So if the optic goes on top of it, we're very likely to cut into that plunger hole, and that's going to be a problem. Another thing from the obvious is the firing pin channel. Obviously we would want to cut into that, and that is located 0.215 deep, so just about here. Now, how deep does this optic need to sit? I guess that's a matter of debate, I suppose. I don't know if there's a standard height it's supposed to be at. I know some of these optics have mounting plates, which causes them to be sitting kind of high, so high that the stock sights are no longer visible, and then people have to get raised suppressor sights or something like that, just so that they can witness with stock iron sights, or plastic in this case, with an optic. But my goal is that this sits low enough where the stock sight is still visible. And we can do that because we're cutting the seat specifically for this optic. We're not going to be using any plates, any adapters, nothing like that. So the height, the depth rather, we have to worry about is 0.215 inches. That's how deep that channel is that we talked about. So we have to cut away less material so that we don't intrude on that, and we have to stay away from this plunger hole. Now, from what it looks like, this is that plunger hole right there, you can see it. From what it looks like, I can cut this, I can position it just about here so that it's very close to the rear sight, but not so close that we have to basically make it unusable. You know, there's still enough material here to hold that rear sight. And then if this optic is positioned just about here, and the seat for this cut exactly with the radius of the front and the back of this optic, it's going to clear that plunger hole. Now, next question is, how deep do we need to cut it? Now remember, 215 is our limit, but how deep do we need to go? Well, we can see. If you look from the back, this notch right here, this is basically a rear sight notch. Here we have 0.277, but we don't need to go that deep, and the reason we don't need to go that deep is because that notch has to be just about in line with this rear sight notch, or even slightly above it. We'll still be able to see the front sight, I believe. So in order for that to work, we have to subtract from 277 the height of the rear sight notch. This is not the most precise thing, obviously, but it's close enough. And we get 0.78. So basically, if we cut this to just about 200 deep, this notch is going to be just about in line with this notch, so that the stock sights could be co-witnessed, and we're going to be clear of this channel, hopefully. I'm going to be clear of that channel of just about 15 thousandths, which is actually not much at all. So we have very little room for error. I think we should actually raise this by another 15 thousandths or so, to about 300ths or 30 thousandths. So that way we have a little bit more of safety margin there between the channel. And then we're going to be just a hair above the rear sight notch there, and should still be able to co-witness, I think. I think we should still be able to co-witness those sights. I don't know, we'll have to see. Okay, so next question. How do we actually secure the sight to the slide? Look at the bottom of the sight. You'll notice two holes. These two holes are for the mounting screws that go from the top. These are the screws that were supplied with the optic. Just like so. So these are going to protrude right into the slide. We'll have to cut holes for those, obviously, but also we have these two indentations, or other blind holes. These are positioning holes, I guess, for the original mounting plate, or if you leave those divots here in the metal, they help position the slide to keep it zero and to hold it steady under recoil. Obviously, 2 points of contact or 2 points of attachment, just these two screws, even though it's going to be probably secure enough, but it's not enough typically to hold this down. So the two front connection points are also required, unless what I think of doing is cutting the seat, the front and the back radius, exactly the same radius and the same dimensions as the slide. If I do that, then the slide is just going to be a very good, not interference, not a press, but very tight fit, which will in itself secure it to the slide, so it's not going to move back and forth, side to side, or rotate on its own. It's going to be enough to hold it in place under recoil, or if you have to use it to charge the gun or anything like this. So the primary stresses are going to be on the front and the back edge of that seat, as opposed to the mounting screws. The mounting screws are just going to firmly hold it down so that it doesn't pop out from the pocket, but the pocket itself is going to provide is going to make sure that it doesn't move around there. So I think that's going to be good enough, in my opinion. And the reason I'm saying that is because even though ideally you would want to remove all of this material except the two little pins that would interfere with these two blind holes, but I have a manual mill, and I don't think I can do this on my mill. I just don't have the precision or the tooling really to cut this wall, and also these two protruding pins. I don't think that I'm going to be able to do that. I'm going to mess it up. And then if it's not going to be as tight as it needs to be, where these two pins go exactly into these two holes, then it pretty much defeats the purpose. Because if it's not precise and it doesn't hold it down, then what's the point of doing it, right? It's not going to hold it the side down from moving back and forth or side to side or in any of those directions. So that's pretty much a useless exercise in my opinion. I don't have the tools or frankly the skill set to cut those accurate pins. So I'm just going to rely on the front and the back radius, like I said. And hopefully that's going to be good enough. So that's the plan. That's the plan so far. Alright, so this is the rough outline. Alright, so the cut you saw me made was this cut right here. I didn't start recording from the very beginning, unfortunately, but this is what we have. You will notice that it's not straight, or at least it's more straight on this side and skewed on this side. And that's because I forgot to tighten the rotary table that this was fixtured on. So as this was going up and down against the cutter, the table slowly turned ever so slightly, and that's why it's uneven, which is fine because these guides, you see that those little scribe marks in the back and in the front that I scribed are a little bit undersized. So when I cut the actual final cut, this little mistake is not going to be it's not going to be obvious. In fact, it's not going to be visible at all. So I cut this to 180 thousandths, just 5 thousandths short of 185 that I was planning to do. And oh, I don't know what Glock does to these slides, but they're super hard. I don't know if this is the finish or it's case hardened or something, but I dulled 2 new end mills. This is the first one, it was brand new. Dulled immediately as soon as I tried cutting that stuff. And I was going light, only 20 thousandths depth of cut. Then I changed it, I thought maybe this was a bad end mill or something. Changed it to this one. Same thing. Dulled immediately. So I had to go with my trusty old carbide cutter, which is in terrible shape, as you can see. It's got a big chip right there. It's chipped all the way around, but I still cut this just fine. It's not pretty, I know, but this was a rough cut just to get most of the material out of the way. I will come in, when I do the radii, I will come in with a smaller fresh end mill, and hopefully I'll be able to clean all of that up and then go down to the exact dimension. The radius, this radius and this radius. I don't know what Holosun did, but these radii are different. The back radius, diameter rather, is 4.675, and then the front diameter is 5.645. And the way I found that out is I just took a piece of large stock of aluminum and turned it on the mill, bored it until I could have an exact fit of the back and then the front diameter. I don't have feeler gauges, and there was no other accurate way that I could think of to measure those. So that's what they are. Once again, 4.675 for the back and 5.645 diameters for the front. To get the radius, you have to obviously divide it by 2 and then subtract the radius of your end mill and all of that if you're going to be doing that. So that's the next step. We're going to put this on the rotary table, measure those radii, and then cut the final radius to size here on the front and in the back. Let's do this. So this may look like there's a lot going on, but here's the deal. Slide, obviously. This is indicated straight with the center of the rotary table. The spindle is indicated to the center of the rotary table and offset that exact value for the right radius to be cut here. Lower it. And then rotate the table. This is going to cut the correct radius. Then we're going to take it off, flip it around, adjust the radius, and cut the other side. Let's get cutting. So the same setup here, but in reverse. We flipped it out, adjusted this radius as indicated to the center of the rotary table. The center line is still indicated to the rotary table, so that's not a problem. We're gonna dip down to find that Z and then just go rotating. That's the plan. Oh, and off camera, I just went ahead and I milled this out to get it to the final depth, which is 0.185. That's what you see here, and we're going to do the same thing on this side. Yep, that's it. Yeah, that's a tight fit. Exactly how I want. Alright, let's disassemble this. Alright, so the cut is done. Came pretty close. This is pretty much press fit, as you could see me try there. Now, one obvious thing is this. As you can see, we did encroach into that plunger hole. I should have moved this cut a little bit further back towards the rear side, but I didn't, and so we did encroach on this hole, which is not a problem because, well, it's not gonna impede the operation in any way, obviously. But we do have to take precautions. We have to make sure that that channel on the inside is deburred, because when fully depressed, the plunger does reach this hole. Come to think of it, actually, it is going to be a problem, because that plunger is now going to impede or come in contact with the sight, which is obviously a problem. Let's see. Maybe not, actually. This is how far it goes when it's depressed. That's it. Alright, I guess we avoided a bigger issue, but still, this is not ideal. I should have moved this further back. Well, you know what they say. Measure once, cut twice. Next steps, well, test fit. Alright, I think it's in. Gonna give it a little bit of a tappy tap tap. I don't see any daylight here. I think we're good. Do we have co-witness? Yes, we do. Well, kinda. Let's say almost. Oh, this is not sighted in, obviously. But yeah, this ain't bad. Next step, drill and tap these holes. So to tap these holes, I have just the tool for the job. These little centering punches. This is the right size. It's very snug. Maybe too snug, actually. No, this is the right one. Alright, I got to the metal. I'm gonna give it a tap. Hit the camera. Okay. So you see now I have a perfectly centered tap hole. Tap there. Can do the same thing with the other. These are supposed to be hardened, but it's mushrooming pretty good. I don't know if that's because Glock is using some kind of hard steel, or maybe these are not the best quality. I got them off some guy on Marketplace. They were new. Metal. Getting this thing off is a challenge. I'm gonna use the vise off camera. Alright, so these are the two holes. Obviously, this right one is going to interfere with the extractor plunger hole, which is to be expected. I think I'm just gonna drill it straight through that hole, through that channel rather, tap it, and then deburr the channel on the inside, and then cut the screw or the bolt to size so that it does not interfere with the plunger. When the plunger sits like this, that means that screw is going to potentially come in contact in this area, which is fine. As long as I make that screw flush with the hole, it's going to allow the plunger to operate normally and also to be removed and inserted without any issues. I hope. Let's find out. All right, assembly time. So what I did is I sanded this down a little bit, and then I applied Brownell's liquid gun blue, which I'm not too happy with, to be honest. But I do know that Glock uses some fancy steels or heat treated. I don't know what's going on. You see, like here by the edge, just no matter what I did, the gun blue would not do anything to those areas, and then just random spots for some reason. I don't know what's going on. I'm gonna leave it as is, and then hopefully it doesn't rust too badly. Well, we'll have to see about that. In any case, let's put this thing together. Oh, and yeah, I did do the holes. I drilled and tapped them off camera because my mill, which has the camera attached to it, does not have a chuck small enough to take this size drill and tap. So I just had to do it on the drill press and then tap it by hand, which was not too bad. Now this hole went through this this channel for the extractor plunger, as we talked about. But what I did is I chased it down with appropriate size drill bit to make sure there's no burrs or anything like this. And then when we put this together, we're going to trim this screw to make sure that it does not interfere with the plunger operation. So this is really tight, as you could tell. Yeah, I think that's on. Final assembly time. Okay, so I trimmed these two these two bolts so they can both fit. I'm going to use some, where is it? There we go. I'm going to use some Loctite blue lock thread locker rather. There was some that came with it, but I think I stripped it when I was trimming these, so I'm going to apply just a dab more. Come on. Get over here. Oh, that's way too much. So as you can see, this hole is clear for the plunger. We can test this operation. Actually, let's test all the operation, why not? Uh-huh. It does bind a little bit, that's strange. That's much better. Must have been some debris in there. Looks good to me. Just gonna clean it up and sight this thing. Should be good to go. Yeah, as you can see, it's interfering with the sight just a little bit, but not enough to prevent you from using it. So if your red dot goes out and you need the backup, you can still use the stock sights. Nice. So a little bit thicker than the slide. There you go.